All right, the next topic of this section is going to be that of absolute convergence and then conditional convergence. So what is absolute convergence? So given some starting series a sub n, this series we would say converges absolutely if, when you take the absolute value of the general term of the series, so in other words, take all the terms that are being added together and take the absolute value of them. If that new series you obtain also converges, then we say the original series converges absolutely. So determine whether the following series converge absolutely. So let's go ahead and just mention here that in this case, a sub n for this series is going to be negative 1 to the n minus 1 over n. So the absolute value of this a sub n is going to be just 1 over n. So this implies the series of a sub n in absolute value is exactly the series 1 over n, which is the harmonic series, which we know the harmonic series diverges. So this means this series does not converge absolutely. Next series. Notice here that our term 1 over n squared, this term is positive to begin with. So slapping on absolute value bars doesn't change the series term. So regardless, we can just focus on this series. We don't have to think of it as changing because it doesn't change. This series right here converges because it's a p series with p equals 2, which is greater than 1. So the absolute value of the term is the same as the term itself, since the term is positive. So this converges. Technically, it converges absolutely. So let's just emphasize the absolute value of 1 over n squared is just itself 1 over n squared. And since this series converges, this implies that it also converges absolutely. So the takeaway here is if your series terms are positive and your series converges, then it, by definition, converges absolutely. Nothing fancy going on there. All right, this term here, our a sub n, is negative 2 to the n plus 1 over 3 to the n minus 1. So what I could do here is, let's go ahead and multiply by 3 over 3. I'll group one of the 3's in here, so I get 3 to the n. And then I will also take one of these n plus 1 copies of negative 2 away. So this will be negative 2 over, actually, this will just be negative 6, I guess. Negative 6 times negative 2 to the n all over 3 to the n, which is negative 6 times negative 2 thirds to the n. So the absolute value of a sub n we could actually even do one more thing here, I guess. This is negative 1 times 6 times negative 1 to the n times 2 thirds to the n. Which is 6 times negative 1 to the n plus 1 times 2 thirds to the n. So if I take the absolute value of a sub n, this negative component just vanishes, and we have 6 times 2 thirds to the n. And this series here is a geometric series with our common ratio and absolute value less than 1. So converges, which implies the series of a sub n absolutely converges. All right, our series term a sub n is negative 3n squared over 4 plus n squared. So this implies that the absolute value of a sub n is positive 3n squared over 4 plus n squared. And notice here that the limit of this, as n goes to infinity, is equal to 3, which is not 0. So by the divergence test or theorem, this implies the series of absolute a sub n diverges, which is to say that the original series of a sub n does not converge absolutely. Here, our a sub n is negative 1 to the n minus 1 all over n to the 10. So this implies that the absolute value of this is just 1 over n to the 10. Which means this series is a p-series if p equals 10. So this converges, p equals 10, which is more than 1. So that implies this series, the original, converges absolutely.